So one of the things that you're going to do whenever you're playing around with programming a lot of times is you're going to create random numbers to kind of do experiments on. We do this all the time in like stuff, like physicsy stuff. But in general, it's good to know how to create random numbers. Now, whenever I say random numbers, numbers can be anything, like just those decimals. When we say random numbers, we specifically mean things that can be decimals. And when we say random integer, it has to specifically be a whole number. So anytime you hear random number, that means blah, 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 like decimal places. Random integer specifically means like a counting number. Even though I don't never really counted down to negative 29,384, I guess in theory I could. Okay, so there are two different functions that are going to be related to this. So rand is the one that's related to random numbers, and rand_i is the one that's related to random integers. So I wonder if I can just put that there. Yeah. So we have rand_i, which is, that's what I wanted to do. We have rand_i that is related to random integers, and we have rand that is related to random numbers. And random matrices is basically just doing those but turning them into matrices. Okay. Now, let's just start with rand by itself. So if I just type rand and I just run this over and over and over again, you're going to see that I'm going to get a lot of different numbers between 0 and 1. And that's exactly what it does. This gives a random number between 0 and 1. You're like, does it include 0 and 1? I don't know. I guess in theory, maybe. Probably not, because the chances of it getting exactly 0 or exactly 1 are like basically non-existent. But you know, it just sits here and it creates lots of random numbers. It's pretty fantastic. Okay, so random numbers, random numbers, random numbers, random numbers, random numbers. Now you might say, okay, so if I want to generate a random number between 2 and 5, maybe I do this. But no, that generates a 2 by 5 matrix of numbers between 0 and 1. Homework. Taking computational physics for winners, because who wouldn't? So we've got rand, which just generally gives a number between 0 and 1. This here, x equals rand 2 by 5. This does not give a random number between 2 and 5. It gives a matrix of random, gives a 2 by 5 matrix, 2 by 5 matrix of random numbers between 0 and 1. So, you know, things can't be easy. All right, so how do we get random numbers between 2 and 5? Because only being able to generate numbers between 0 and 1 seems pretty limited. Now there's all kinds of ways to do it, and Matlab has special ways, but I'm going to try to show you a way that no matter what programming language you go to, it'll always work, because I'm just going to show you the math behind it. So to do this, let's start how to do this in general. So we're going to call this scaling, maybe? Scaling rand to get whatever you want. All right. So essentially what we're going to start with, and I'm going to show you, and maybe this will help. I'm going to eventually finish the sentence here. All right, let's just start off by having code this. Okay, so this is just 1. Instead of just generating 1 at a time, I'm going to create 10 at a time. Okay, so I put this together. I'm going to make a little histogram. And if you remember what a histogram is a thing that like kind of counts how things are distributed. Come here, histogram. Okay. This is not a great picture, but it's a histogram. So it's basically saying that out of these 10 whatsy-doozitses that I have, it looks like about 6 of them are below a half. Let's see, 1, 2, 3, 4, 5, maybe 5, and only 4 are in the higher bin. 1, do I suck at counting? I think I do. 1, 2, 3, 4. Yeah, I suck at counting. Let's try this again. Okay, so how many are less than a half? This is less than a half. 1, 2, 3, 4, 5, and 6. Okay, there we go. There are 6 that are less than a half. There is 4 that's greater than a half. So that's where the 6 and the 4 come from. Okay, so if this is considered a uniform distribution, which means that over time, I have just as good as a chance of getting, any number in this set. I should have just as good as a chance getting a 0.8 as a 0.2. And you're like, well, here, not quite, but I didn't have very, very many. So what I can do is, instead of only generating 10 numbers, I'm going to generate 1,000 numbers. And you can kind of see what this histogram looks like. So essentially what I've got here is, when I generate 1,000 numbers, this is kind of what that distribution, not kind of, well, this is exactly what this particular distribution of numbers looks like. And every time I run it, I'm going to get a slightly different thing, but they're always going to be kind of on average the same chances of getting the same numbers. Now, to kind of give you an alternative, if I put rand in, that's a normal distribution. Oh, and I need to take this away. So like a normal distribution looks like that. So you have a better chance of getting numbers in the middle than you do of getting numbers on the outside. Okay, so if you need something to compare this to, change rand to rand n to see a normal distribution. Okay, but I'm going to go back to rand. But just so you know, so this would be like a normal distribution. The more points you have, and again, the less points you have on a normal distribution, the less normally it looks. I mean, that one looks, yeah, that doesn't look very good. And I know technically we haven't really talked about how to do histograms or anything fancy. I'm just doing this because I think it helps things make more sense. But the more points you do, the prettier that Gaussian curve looks at the normal curve looks. So I'm going to go back to regular random numbers, and again, the more of these zeros that I put in, the flatter that starts to look. You just get less and less and less. Oh no, I lost my little thingy. Oh no, I didn't. It's down here. Okay. And I have a reason for adding this that will become available, obviously, later. All right, I don't really need that many, so I'm just going to do that. Okay. So let's just say that we're generally convinced that we have an equal chance of getting something down here as we do of getting something up here, as something wherever. Okay, so if we wanted to get, say, I'm going to move this over because, go away. No, like there, yeah. So let's say that I wanted to get a number between 0 and 3. That's all I have to do. Okay, so actually let me make these kind of, I'll pull these apart just so we can kind of have them different. Okay, so that we have them separated out. So I'm going to put this dude here. So this is just your standard dude, like just making its little happinesses of whatever, just doing its thing. So that's this. All right, I'm going to make a new section down here. Section break, and I'm going to start with CLC clear just because it's good to start this new section. So so the X from the previous one isn't messing with this new one. So I'm going to say, so essentially what we can do is if we want the numbers to go from 0 to 3, instead of from 0 to 1, we just need to scale it. So I don't know if you remember, you took a class like college algebra where you did graph transformations where they were like, this is important, you're gonna need it. And you're like, no. Where they're like, you have f of x minus h plus k, except there was like an a here and like a over b or something like that. I don't know. And then they're like, these all mean different things. And you're like, arr. Okay, so what we're doing is we're doing this. We're stretching it. So if you remembered potentially what was going on, this was the horizontal stretchy. So times 3. So now we're getting numbers anywhere between 0 and 3. Because all it's doing is it's taking the numbers that are from 0 to 1 and it's just stretching them out. Okay, so it's just multiplying them by 3 to stretch that scale. And no matter how many times we run it. Now I'm only generating 10,000 numbers so you can kind of see what all the different numbers are. In real life, if I was just looking for one number, I would be like rand times 3. And it would give me, there's a number randomly between 0 and 3, but it's kind of hard when you're just, this is the number I'm trying to have you look at right here. It's kind of hard when you're just looking at one number at a time to see what it's doing. So that's why I'm generating 10,000 numbers at once. You can kind of see where the whole set of numbers is going. Like I haven't seen anything that's a 1 point for a while and it's kind of freaking me out. There's a 1 point. Okay. So if you're just looking for one number by itself, it'd just be rand times 3. Okay. So if you want to kind of keep that to remember. But there's your histogram. So if you want to scale the numbers to go a certain width, then that's the width you want them to go. Okay, now, the next thing that we might want to do with them, section break and make some code, is now maybe we want the numbers to go, now we want them not to start at 0. So let's say, let's start them, let's go from 7 to 10. And I did that on purpose because now all I have to do is go plus 7. So now see what that's doing. So if I look at this code, okay, it's going from 7 to 10. So it still has a width of 3, right? And it's been shifted by 7, right? So it still has a width of 3 and it's been shifted by 7. Kind of see it? Kind of see it. Sort of-ish. Width of 3, shifted by 7. And that's how that works. If you want to go from any number to any other number, you figure out what the width is, and then you figure out how much you want to shift it by. And that's really all you have to do. And if you want to do a histogram, if you don't have to remember what this is, the only thing that's doing is it's forcing the bottom X thingy to start at 0. If you just do this, it'll still give you that. It'll just not be as obvious, but it's still going from 7 to 10. So if you're kind of doing code and you're like, I can't remember if I got this right, just do a histogram right quick. And you can be like, oh yeah, the numbers go from 7 to 10, yay. So I'm gonna throw that back in there though, because I think it's a little bit more obvious what's going on. So again, you're gonna take your random number, and again, you don't have to, what's he use it's, you don't normally need to be generating 10,000 numbers. If I want just one number from 7 to 10, I would just do rand times 3 plus 7. And so that number there, this just one number here thingy, is always going to be between 7 and 10. And again, it's easier to see. I mean, you can do this like a couple thousand times individually and see, yeah, that number is probably always going to be there. But I just like to plot the histogram because I think it's a little bit easier to see that, yeah, okay, over time you get for surezies what you're looking for. Okay, so let's practice a little bit. I'm going to give you a couple to kind of play with on your own. Like, see if you can get a random number from, I don't know, from 3 to 7. So try to do that one. And then try to do, and you can do the full histogram if you want just to check it, but this one is just a random number. And then do a 5 by 7 random or matrix of random numbers, can't spell, from 5 by 7 random matrix of random numbers from 5 to 7, because why not? Oh, let's make a negative from -5 to +7, because that'll be fun. All right, so at this point you should pause the video and see if you can figure these out. Okay, so we're gonna pretend you did that. Okay, so if we're looking at this, if we think about a random number from 3 to 7, from 3 to 7 it has a width of 4, right? So if we're normally going from 0 to 1, it's going to need, instead of having a width of 1, it's going to need to have a width of 4. And then it needs to be shifted, instead of starting at 0, it needs to be shifted to 3. Okay, so let's do that. X is going to be a random number times 4 shifted 3 in the positive direction. So now if I just do this a whole bunch, I can generally see I'm getting numbers between 3 and 7, which is pretty fabulous. So that's great. Awesome, awesome, awesome. Okay, now I want a 5 by 7 matrix of random numbers from -5 to 7. So this has a width of something stupid. Width of, hold on, that's like 10. What's 7 minus a -5? It's 7 plus 5, right, is 12? Math is Howard. Yeah, 12 has a width of 12, and it's shifted to -5. Okay, so I need a 5 by 7 matrix, and it's got a width of 12, and it's shifted to -5. Now, all these numbers here should be between -5 and 7. And it's kind of hard for me to tell. I wonder if I can histogram it really quick. What are you doing? Oh, because it's, I don't know what it's doing. Well, the numbers appear to be between something and something. I can't exactly tell what's going on. I don't like this very much. Why are you doing this? You're making my life complicated. I think it doesn't like the 5 by 7-ishness. What if I just, let me just do this right quick. No, not 1,000 by 1,000. A 1 by 1,000, sorry. Okay, so these numbers should be between -5 and 7. Okay, that looks better. Okay, I'm more convinced that I've done this right. -5. Here, if you want to, you can pop this out. And I think if you expand it, it might give you more information. Maybe not. Maybe it's just going to be a dork. Yeah, -5. Okay, and then go back to the home screen and come here, girl. And 7. Okay, so yes, that is what I wanted it to be, so that's good. And now I just need to go back to it being a 5 by 7 matrix. Beautiful. And I don't need this histogram anymore. Okay, so a 5 by 7 matrix of random numbers. All right, so that's how you can get random numbers. Random numbers? Okay. Now, I did promise you random integers. So, like I said, random integers are different. Than random numbers, because they're integers and not numbers, just in case you weren't sure. And the code that we're going to use for that is called randi. So randi 6. So if I just run this over and over and over again, it's going to see that you're getting numbers between 1 and 6. Okay. So this specifically, can't spell. This is giving me numbers between 1 and 6. Notice it does not include 0. Not 0. And no negatives and no nothing. This is really meant to be like rolling the dice. So this is meant to feel like, I'll just say that. Randi is meant to feel like you're rolling the dice or randomly drawing a card or something real-ish, you know, a flipping a coin. So I could be like, if I'm flipping a coin, it's heads or tails, heads or tails, heads or tails, heads or tails kind of a thing, okay? But randi is always going to give me a integer that will be either a 1, 2, 3, 4, all the way up to whatever number I give it here. So it's always an integer, and there are reasons I might want to do this. Like I said, a lot of times if you're rolling a dice, you're not going to have you're not going to roll a 5.3. So, and there are reasons why you wouldn't want to roll a regular, what do you call it? number and round because it can bias the endpoint. Anyway, so don't worry about it. Just trust me that if you want to do dice or cards or something like this, go ahead and use rand I because it's going to be better. Now, as you're typing, if you start to do this, you'll see, okay, it says I'm max. So that's giving you the integer max that it might be that you're looking for. So if I just plug in 10. Now, you see after that it has SZ. And I believe that's going to be a size that you could put in. That's right. Okay, SZ is size. Okay, so that is giving me a 3x4 matrix of random integers from 0 to 10. So again, I could do a 1 by 10,000 of just like a ton of integers. I could histogram this and get all those numbers between 0 and 10, or between 1 and 10, and that's perfectly fine. So, but they're all, again, they're exactly the numbers you would expect them. This is the exact numbers, they're not, what do you call it? They're exact integers, they're not numbers in between, they're not continuous numbers, they're not rando decimal places. So, but you're still getting that norm. I guess what I'm trying to say is you're still getting that uniform distribution where you have just as good of a chance of getting one set of numbers as you do of having the next set of numbers. Okay, so you're still getting the generally same set of numbers. So I'm just going to go back to 2 by 3. So this gives me, I can't spell. This gives me a 2 by 3 matrix of random integers between 1 and 10. Again, not 0. So again, if you wanted, you could, what's-he doozy it? If you're like, I don't want to go between 1 and 10, if you wanted to go from, I don't know, if you wanted to go from 11 to 20, I don't know if I want to use that one. I think you can actually do this a little bit easier. Let me see. I'm going to go down to this, and I'm going to type help randi. Oh, you can actually specify I'm in Imax right there in randi if you want. So you could be like, I want to go from 12 to 20, a 2 by 3 matrix going from 12 to 20. Okay, so I can't spell. This gives me a 2 by 3 matrix of random integers from 12 to 20. But I could also do the same thing I did before, where I say, okay, so the width last of this 12 to 20 is 8, right? Because I'm like, hold on, if I subtract, hold on, I'm gonna try this again. So if I go 12 minus 11 is 1, 20 minus 11 is, I can do this. No, maybe I can't. What's 20 minus 11? 9. Okay, I should have been able to do that. Okay, so now I want to go from 1 to 9. And I want to go, so go from, so generate from 1 to 9 and shift by, because it starts at 1, shift back up by 11. And that should also give me, yeah, numbers between, so you can do it that way too, I guess is where I'm going with this, is, I'll say this here. This, oops. This also gives me a 2 by 3 matrix of random integers from 12 to 20. So basically I can say, well, these are 9 apart, or it has a width of 9 if I count the fact that I'm starting at I have to do it like this because it has a weird endpoint thing, right? Because it's not starting at 0. To get down to 1, then I shift both of them by down this much. So now I need to go from 1 to 9, and then I need to shift it back forward by 11. So you can do it that way as well. It's not the best way. This way is probably more obvious. I think if I was looking at this code, because see, if you just try to go out here and multiply by 9, you would only end up with numbers that were, yeah, I'll show you that because that'll be funny. So if you try to do this, randi 1, 2 by 3, and then you're like, oh, that's okay, I'll just multiply by 9 and add 11, you're just going to get all 20s because you're just generating the number 1, and then you're multiplying it by 9 to give you the number 9, and then you're adding 11, which gives you the number 20. So you can't do that same thing with randi because you're not generating numbers, you're generating integers. So, I mean, if you were looking for a way to kind of do it the same way with randi, you can. Otherwise, you can do it like this. But again, it's one of those things that sometimes you just need some matrices to play with. So being able to generate random matrices, again, just to play with, can be actually kind of helpful. So randi and rand are a good way to do it. And again, if you for some reason need a normal distribution, you can learn more about rand-n, which is a normal distribution where you can just indicate doopy-doopy-doo, come here, if you want, and I think you can change, yeah, matrix, and you can mess around with, yeah, mean 1, standard deviation 2, so you can change the mean by adding, and you can change the standard deviation by multiplying. So you can kind of do the same thing there if for some reason you need pseudo-random. Now technically, you're going to notice that these say pseudo-random because technically they're not random, because if they're being generated by an algorithm, they're not actually random. But that's like, now we're getting into computational philosophy. I know it's a real thing, but I don't care right now, and it doesn't matter for the purposes of what we're doing. But you can also generate normal distribution numbers with mean and different standard deviation if that's something that you need to do. So yeah, so now you can, whenever eventually you want to go play with functions, you can generate random matrices and just kind of see what the various functions do with them. Pretty fun.